Machine learning is the new norm in the modern world of data science. There are several algorithms and models such as artificial neural network, logistic regression, decision tree, random forest, amongst others. And in my case, I used artificial neural network and logistic regression analysis. My name is Rachael Wanjiru Njoroge. I'm a data scientist based in Nairobi, Kenya. I published a paper on modeling breast cancer risks using artificial neural network, a case study of Kenyatta National Hospital. I co-authored with Professor Waititu and Dr. Wanjoya. This paper is published on the International Journal for Science and Research. Background information. Breast cancer in Africa occurs at an early stage as compared to Europe, according to Abdrahman G. et al. 2012. And according to the International Agency for Research on Cancer, the cause of high mortality in Eastern Africa is because cancer is presented at the later stage, and the study was carried out in Kenya, which is a developing country in East Africa. Kenyatta National Hospital is Kenya's national referral hospital located in the country's capital city, Nairobi. The female incidence rate was 1.08 per 100,000 persons, and the incidence rate has been on the rise according to the Nairobi Cancer Registry. Review of the previous studies. A research done by IRT et al. 2010 on breast cancer risk estimation with artificial neural network ANN showed that the ANN can effectively discriminate between cancerous and non-cancerous abnormalities of the breast for individuals. They built a feed-forward artificial neural network of size 1000, which consisted of 36 independent variables. Materials and methods. Secondary data was collected from Kenyatta National Hospital. Data collected was for the years 2009 to 2014. Demographic factors and mammographic findings of patients at risk of breast cancer were used as independent variables. The dependent variable was biopsy outcome, and those with the missing information in their files were not included in the study. Ethical clearance. This study was approved by the KNH/UON-ERC committee. The committee is a joint board between KNH and University of Nairobi. The artificial neural network model. A neural network contains three layers, namely input layer, hidden layer, and output layer. The input-output map consists of D input nodes, H hidden nodes, and an activation function. The training of the network. The weights of network are chosen such that the error is minimal, and in this case we used quasi-Newton method, which was independently developed by the authors Broyden, Fletcher, and Goldfarb. The logistic regression model. The logistic regression model is a category of a generalized linear model, and it is used to model discrete outcomes which are binary in nature. Results. Independent variables were used were 21. Biopsy outcome was coded as 0 for benign and 1 for malignant. Age. Majority of breast cancer patients were aged between 35 to 55. Education. Majority of patients with breast cancer were in the category of primary education and below, which was coded as 2, and this category had a frequency of 119. Gender. There were more women than men who had breast cancer with a frequency of 302. The artificial neural network model was fitted. This specific model was defined as below. The training dataset consisted of 320 observations out of 370. The R code used is as shown below, which is nn.nnet. nn.nnet is just a name for the model. The new X there is the name for the independent variables, Y is the dependent variable, and data train is how we named the data we used to train. Then the size we used was 23. Then entropy we used it to be true, and then the absolute value was 0.0001. Choosing the number of hidden nodes, a neural network of size 1 to 24 was matched with their respective R-square value. So R-square was then iterated 1000 times, and the mean was obtained for each size of the ANN. So the optimal size was found to be 23 with an R-square of 0.996. This is because 23 had the highest value of R-square. The sensitivity analysis for the artificial neural network and the respective confusion matrix. The sensitivity is actually defined as the misclassification error when the response is true, and specificity is the misclassification error when response is false. So for the ANN, there were no false positives and there were no false negatives. Hence, ANN had a very good predictive capability as shown in the confusion matrix below. So the ROC for the artificial neural network is as shown below. Logistic regression analysis. So the significant independent variables are at 5% level of significance. There were as follows: age, patients aged between 35 to 55 years or at a higher risk of breast cancer. Then education, patients who had a level of education of primary and below were at a higher risk of breast cancer. This could be attributed to ignorance. Breast density, patients with breast dense were deemed to have a higher risk of breast cancer. Calcification, patients with microcalcification were at a higher risk of breast cancer. The reduced logistic regression model was obtained using the stepwise AIC. Hence, the formula used is as shown: biopsy regressed against age, menopause, personal history, breast density, and calcification. And of course, the family of the logistic regression is binomial. The confusion matrix, there were 7 false positives and 8 false negatives as shown in the confusion matrix. So the ROC for the logistic regression is as shown below. The AUC for the logistic regression model was 0.9890909, while AUC for the artificial neural network was 1. Hence, ANN was found to be a better model than the logistic regression model in terms of discrimination capability. The predicted outcome was approximately the same as the original biopsy outcome for both models as shown in the table below. Summary and conclusions. The author's artificial neural network had a high discriminative performance and could accurately predict breast cancer risks. According to the author's logistic regression, the following were the crucial breast cancer risks: age, menopause age, personal history, education, breast density, and microcalcification. Most breast cancer patients were aged between 35 to 55 years, which is a younger age compared to the age of breast cancer patients in developed countries. Limitation. Missing information in patient files was one limitation. Then the other limitation was the long duration to obtain the ethical clearance. Recommendations. The Kenyan government should increase breast cancer awareness campaign. Number 2, Kenyatta National Hospital should digitalize all patients' information to reduce missing information. And number 3, further research using a larger dataset is also recommended. So the references are shown below. Those are the references used. This presentation was done by Rachael Njoroge, the author of this paper. Thank you for listening.